Hello again. Back to hopefully exactly where we were before. This is in case you don't know, you're stepping right into the middle of us stepping through a piece of code. So this is actually a continuation of the last video in this series. There are a few things I wanted to mention that I noticed. Some things I should say before going on. The last time I mentioned this thing about the static data and that it wasn't actually necessary. In fact, it's completely necessary, as it turns out, because all this area happens to be filled with mostly zeros, and so it's important that we copy those zeros over, because the parser assumes those zeros are there and doesn't try to null terminate its strings. It knows that the table where the static data is stored contains all zeros. In particular as well, even more particularly, the first 2 bytes of that area are the argc count, and if that's not 0, then we might get any kind of random number. So that part is a requirement. The other thing is, another requirement is the setting of this terminator character to 0. All of these functions, and this is related to actually the third thing I want to mention, which is having to do with some stuff I cut out. This terminator character. This terminator character, although it appears as though it follows the code, the way that this function references that terminator character is simply by using brackets. It writes something like, bracket something. H there. In order to retrieve the value of that character, there's a use of brackets. And all these bracket things have default segment values associated with them. That is, sometimes bracket something means this. And sometimes bracket something means this. And sometimes it means that, this, and so on and so forth. Now, this function assumes that it's a COM program, so it knows that it doesn't need to specify any sort of segment. So it's just going to use, as it does, the bracket operator and expect to get something from the code segment. If it knew what we were up to, it would have to put some kind of specifier here to say that it wants to retrieve that something, whatever it is, from the code segment. So that's fine. There's no need to change this function, because its assumption is valid. It is in a COM program, and so it's our job to take over what we know. The fact that we know that what we're doing right now is stepping out of the COM world and into another world. So we have to set in our new world the terminator character, and this one will dutifully set it using no override, and it'll whatever it sets, whether it's DS or ES or whatever, will be appropriate to our current place. So this part is necessary. Now, so that's the second bit. And yeah, well, I kind of just mentioned that now there was a bit that you probably noticed I cut out of the last one, and that was my botched attempt at trying to explain about these default segments. One of them, the BP, this base pointer as it's called, always refers to the stack segment. So that is, if you write down move into AX BP plus 4, as we do over and over again, this is assumed to be coming from SS, which, as you can see down here, is actually not in our strange space. We're still using the stack from the real world, or whatever you want to call it. We're from the same segment as the code. Okay, so that's fine. However, if we try to, suppose we managed to retrieve, or we just took out the value of BP, okay, like this, all right, or even worse, BX. And now on the next line, we wrote something like move into AX DX, or maybe I add 4, just to make it look like the last one. Another seemingly equivalent way to do what I just did would be to add 4 to this BX, which I've taken from BP, add 4, and then do that. You'd think that you would get the same result, but it turns out that this assignment assumes that it's preceded by a DS override. So that particular assignment would come from DS. And what I was trying to explain was this fact that because of these default segments for the various registers, when they're different, you have to really be specific. If I know I want something from the stack, okay, fine, I'll use BP. If I have a pointer that came from the stack, I have to make sure to specify, if I'm going to use brackets and it's in the wrong register, I'm going to make sure to override the default and tell this move to come from the stack. Okay, so I just wanted to clarify that. I don't know how clear it is, but just remember that there are defaults, and be careful in a situation like this, because you might get nailed by the default. The DOS debug dump function, for instance, allocates 100 bytes from the stack and then uses SI and DI to access that data. So that function wouldn't work in this scenario if we just called it without doing some fixing up before calling. We would have to restore all the segments and then call it and then put everything back again. And in fact, there's a place in the code where I have to do that. Alright, now this is where we actually are in the program, and in here I've written down, I traced these out, the two PSPs, and I don't know how best to indicate that there's a difference, but I put brackets here to show what's different between these two when the differences come up. So we can always refer back to this little picture if we want to see what's changed. Or every time something happens, what I can do is dump this one out and then just overwrite this. And I'll lose my brackets, but hopefully we can figure out what's changed. It's not hard. Okay. Next, we're going to call this remove escapes. Now, the job of this function is to take any sequence like this that it finds, and in the end, we want that to turn into a single quote. However, we still haven't done the quote parsing part, which is why I want to do this first. These quotes I don't want to be interpreted as quotes, so I got to get rid of them and replace them with something that's not a quote. And as I mentioned before, I chose D for. I'm going to use D for that because there are no D's ahead of this null terminator we just added, and so therefore I know that if I turn this into a D, and any D's I find later on, I can turn back into quotes, and I'll know that that's what it was originally. Okay, so let's see what that function does and how it works. Remove escapes. Well, I called it remove escapes, thinking that there might be more than one type of escape, but I tried various combinations, and as far as I can tell, the slash character only seems to have an effect on quotes, and that's good to know. One thing I haven't checked and I'm curious to know about are those redirection arrows and bars and things. You know, what does it do with those? And if those do get passed in to the command line, then we should get rid of them. They should not be given to our main, as is normal. They aren't normally given. Okay. Now, this function itself obviously doesn't do very much on its own. All the work's being passed on to this function called slash to DQ, or slash DQ to CR. Okay, so that means slash double quote to CR, carriage return, which is a D. Yeah, I'll never get those straight in my head, but anyway, D is definitely a carriage return. I know because if I've written it down by now, I've made sure which one it is before I wrote it down. Well, one way to think of it, actually, if you've ever seen a typewriter, I don't know if you even know what a typewriter is, but it's a thing for typing in with a keyboard, letters and things on actual paper. And the way that thing works for the carriage return and line feed is you press a button, and that that gives a line feed. That is, it rotates a roller kind of downwards. Some roller moves down, and then you got to pull this crank. Okay, I just cut out a whole section of me trying to explain why D is a carriage return when I believe it's a line feed. And I'll never get it straight, but I want to see what happens with this test. I want to write out a file that just contains a D no A, and see where the cursor ends up. So it's going to write out, this is a test, D, hopefully, and that's E, E, F, E byte. Now I suppose I have to say type. Where is it? Carriage return or line feed? I just want it to not come back to the command line. But it certainly didn't give me an extra line. Let me see if I've changed that to an A. That's over at E there. A. Oops. Enter. E. Got it. Try it again. 10E. A. Right. Let me jump first. Now it's an A. Same thing. How can I tell? Hang on, I'm going to pause and I'm going to find out. Okay, I figured it out. This one is a carriage return. You see? I changed the size and I added another line and I put a D here. D, carriage return means to go to the beginning of the line. Okay? So the printout I got for this text says plus some test. That would be true if it typed this part out up to test and then went back to the beginning of the line and then printed out the next bit. And if I turn this into an A, okay, write that out, type out the file, I get a new line. So this A is a line feed and D is a carriage return. So this is correct. This is the right answer. And this is wrong. What I've been calling carriage return is really a line feed, and a line feed is really, a D is really a line feed. Sorry, a carriage return. A is a line feed. I got it backwards. I always get it backwards. It's not really relevant, is it? One's a D and one's an A. But they always occur in the I know this is a waste of time, but it's kind of been bothering me for ages. It's always ODOA, and that, according to this rule, means carriage return, then line feed. Here I've been downloading this video, and I hope that that this video is going to show me how it used to work on a typewriter. A typewriter is a machine for typing things directly on paper. Now, where is it gone? Download. Okay, typewriter, where are we? Okay, now, I guess I'll pause this and run through it, and if I learn anything, I'll let you know. It's amazing. Okay, now watch this. I wonder if I can slow this down. Play speed. Oh, I know. Yeah, there we go. Okay, this is slow motion. Did you see that? Watch. I don't know if I can go slower. It happens in one step. She pulls this crank, and the roller goes up at the same time that she's doing the return. So I can't tell what the order is on an old typewriter. It looks like it's, who's to say what happened first? Definitely the line feed definitely happened before the return completed. All right, because you got to pull the crank, and the crank, go back to that spot again. No, I can speed it up a bit. You got to pull the crank to make. See, in order to make it go up like that. I'm just trying to think of a way that I can remember. If I knew the order, because I know the order, what the order is in a file, it's always D, then A. Okay, now this sequence was line feed, then return. And DA would say line feed and return, but this is actually a carriage return. So the order is actually carriage return then line feed in a file. So it's opposite of typewriter. I gotta remember that rule. Alright, sorry about that. So this thing will in fact convert slash quote sequences into carriage returns. The carriage return is when the roller goes back to the front. Let's see now. So, okay, this is some kind of loop, obviously, and it's using stir-cur. And my comment here is take the old hag out for a walk, because I've been using the stir-nlen for everything now, and I've kind of forgotten about my friend stir-cur that also does character seeking. And I like to make sure that these functions are still working, so I decided to use that one, even though I could use either. Now, 5C is a slash. That's the reason why I'm using the numbers rather than symbol names again is because of this batch file compiling thing, which as you add more and more, each time you add another symbol or label, multiplies the length of time that it takes to complete by a factor of 2 or something. It's because of the way the command interpreter works with those you can call a label inside a batch file. Okay, and you would think, no problem, that's fine. And I do a lot of that for the search replace. In fact, on every line, it's going to call a search replacer thing for each search replacement. Now, if there were 20, that means there's 20 calls per line. All right. Now, each call, as it turns out, creates a whole new instance of the command processor again. So each line creates then 20 instances of the command processor, and going through all the search replacements for that single line. And if you add another search replacement, then it's going to add. You see what I'm saying? It's a horrific, slow process when you add another label, and I want to get rid of that. In fact, once this program's done, I'm going to write a proper search replacer program using this code. So it's like the lever idea. We have this crummy batch thing, and with that we can use that to make something that can do a quick search replace. And I want to be able to add numbers, for instance, inside to be able to use a symbol instead of having to make up a new name when I want to add 2 to something. And many other kinds of replacements I'd like. Okay, anyway, search for slash, clean up stack. Now this thing returns null if it doesn't find it. So if null, if 0, go to done, didn't find a slash. Now this uses whatever the terminating character is, in this case null. It doesn't need to know. If it does find a 5c, which is the slash, it increments whatever's in AX, which was the return value, so that's the location of the slash, moves that value into BX. Now into A low goes what's pointed at by BX, which should be a quote, or we're checking to see if that's a quote. So here we have a position, we have a pointer AX. This is the address of the slash. And we add 1, up here before adding 1. Oops. Before adding 1, that's sort of in the middle, isn't it? Before adding 1, it's the address of the slash, and then we add 1 to AX, and the question is it a quote? That would be our question, right? So in order to do that, we can't use the brackets with AX, so we have to move it into a thing that likes brackets, and BX is 1, and now we're moving into A low, the byte value contained at BX. So now we're basically saying A low, the register value equals pretty much AX, right? But we changed it into a B. Now this tells it automatically to extract only a byte from this pointer, and there B is pointing at this question mark. Now first, is it a null? So this is checking if it was the last character. Are we on the last character? Because that would be the null, and if that's true, then we're done. It's definitely not a quote. Now we're comparing it with quote. Is it a quote? And if it's not 0, means that this test was not. This is like not equal. So if it's not equal, go to scan again, and that's up here, I think. So that's a pretty obvious little loop. And eventually, if it does find a quote, now the BX value, which is pointing at the quote here, is being given to strlen. So we want to find the length of the string from the position of the quote. So now AX contains the length of the. So if there were a slash quote in our command line, which there isn't, but if say it was this one, then the length. In fact, this is better because we're using the null terminator here. The strlen would give us the distance from here to here. Okay. Now add 1 extra to include the null terminator. That's important. What we're doing is like a copy down. That's why this is being specific about the type of copy that it needs. A forwards copy. If you're copying downwards, basically we're deleting this quote. We're deleting the character here. And we're going to, so it's a copy down. We're going to take everything from this, if it was this one, this would become F, and then the U would shift here, and everything would go down more. Just as you'll notice, by the way, that this command line ends here. And you'll notice another thing, that there's a little leftover bit. Have you been noticing it before? There's always a leftover bit from the command line here. And I counted this up, and I had a good guess as to what this is, why this is here. Because the command line here would have been taken from debug, right? Like this is debug of our program, and then the command line, right? So this should be the length of the name of this program, which is myprog. No, it's C main. CMAINE.com. Oh, C main, and then .com. .C0M. You see that? So the original command line contained our program name, right? And here's a D. See, this was passed into the debugger, and it removed our program name from its command line and passed its command line on to us. But in the process, it must have been doing a copy down, and that's why this is left over from its command line. So another diversion, but also I think interesting. Well, maybe we'll just trot along slowly through this thing. Okay, now, so that's why this is a scan forwards. If you're going to copy things down, okay, so the first thing I would do is take the F and put that here. Then the next position I read from is the U, which would go here, okay. Imagine if you were going the other way around and you wanted to copy up. Suppose I wanted to take this string. Well, I'd like to do it from the same spot, but I can't really. Well, I could, but let's take a simple example. If I wanted to copy the word funny to one position further on, right? Now, the way I would have to do that would not be to use the forward copying. That is, if I did a forward copy, like I am here, then I would have to start here, right? And copy the F onto this spot. But now the U has been wiped out. So the next thing I'm going to get here is I'm going to copy another F here, and then it's just all going to be F's. So in order to do it properly, I've got to copy in a backwards direction, moving things up. So if you're copying down, you have to go forwards, and if you're copying up, you have to go backwards. That's for an overlapped copy, so that you don't recopy the things that you're doing, you're copying. And mem copy has no it is said to be undefined, does not have a well-defined behavior for overlapped regions. You have to use mem move, which checks for this direction thing, and if it's overlapped, then it calls the appropriate function. Another one I need in my library. Okay, so anyway, assuming this was a slash quote, it's copying everything over top of that quote. And it's replacing the value where the quote was with a D. And now, but what about the slash? Yeah, I just want to make sure. Increment. B is pointing one beyond the slash. The slash has got to go away too. Right. You can see that we're checking to see if the copy resulted in there being a null copy to our position, in which case we would quit. That makes sense. But wouldn't there be a slash here? Let's look at this copy. We increment AX includes a null term. So mem copy is destination, then source, and then count. So it should go count. Oh, okay, so this is count, and then source AX, which is one ahead of, well, actually it's the same as BX. Oh, hang on, increment AX, that's just for the count part. And then BX is the source, so that's the quote. I see, okay. So the source pointer is BX. So write these in, it makes it clearer. That's the position of the quote. That's the source. And now it's subtracting one from BX and pushing it. So this is the position of slash. Whoops. So what that means is the quote's going to get copied on top of the slash. If this was a sequence like that, this is our destination, this is our source. So in the end, that would go there. This would be an F. Okay, and then we'd be left with a quote here, which is still being pointed at by BX, turned into a D, which is a carriage return, and that gets rid of the quote. And eventually that D will be turned back into a quote again. So that's the way the slash quote sequences get cleared away when they exist. I probably used way too much time. Yes, I have. But it's okay to look closely at how these things work. So yeah, the test here at the end, again, is, as I said, is something that is required because we don't want to jump past that 0. So it has to be done here before any incrementing goes on. Where's the other increment? It might work actually even without AX. Oh, means next car is no. Compare AX to BX. I'm not exactly sure why that would. Oh, because one of them is the count. I see. It has to do with. It's just somehow it worked out, I guess, that you could quickly hop out of here with a test of AX and BX. But it's not. This is not required code. This is just an efficiency thing, I guess. It turns out that because AX was the count of characters that we would copy, including 0, and BX was the position of the quote character just before the slash, which was decremented, but then incremented again, and the count decremented. It works out, if you work this out, if these are the same, then that means the next character is going to be a no, and so there's nothing left to do but leave. That part you can work out on your own. Okay, so I didn't get a chance to step through it, and in fact it's not going to find any, but I'll leave it here and I'll continue on in the same manner. Just, casual, no need for speed. Okay, see you next time.